Thank you, and thanks for joining me. The big link there is the same presentation online, so if you're way at the back, you can follow it on your phone, and you can look it back later on. So I'm going to talk about a side gig. So it's more for fun than for profit. So if you were here for me arguing a business case to embed C and Elixir, you can still get out and leave. And of course, I'm not on my own laptop. Okay, so my name is Cees de Groot. I am from the Netherlands. I live in Canada. I learned programming on what's called like a Magnavox Odyssey. For metric people, it's a Philips Video Pack 7000 back in '78. Little tech cloud for all the languages that people over the ages paid me to code in. You need to be pretty old to recognize everything. And I'm currently working at PagerDuty, and this is sort of like the tech stack we're using. PagerDuty got started with Rails and later on Scala. Last summer, we decided, after 2 years of production success with Elixir, that going forward, Elixir is going to be our only language for development. And I lost count. We have like the Heisenberg uncertainty principle. If you grow really fast, you cannot count the number of engineers anymore. I think we're like 120 developers that are using Elixir. It's sort of up there. So this talk is not going to be about anything we're doing at PagerDuty. We might use this, but this is a pure hobby project. This is not PagerDuty. Raspberry Pi, and a TFT screen, and a couple of solid-state relays. I bought a new house, and it had like a really crummy heating thermostat. And if you live in Ontario, you don't want a crummy heating thermostat. And I was like, I should be able to temperature sensor. I left it out in the picture. Temperature sensor, some relays, a switch on your stage 1 and your fan or whatever, and like a little display so I can like increase the temperature. Why send money to Nest or Ecobee when I can just rig it up? So I was like, yeah, the temperature stuff is pretty simple. You spawn a process, pulls a sensor, and like switches on and off, and you can do machine learning. So the hard part is like the little display there. How do we go and show something on the display? I didn't want to run an X server on a Raspberry. It sort of offends me. Qt and then a web browser and then a Phoenix thing, like, and then you have to like write everything in HTML and JavaScript, which is probably more offending than having to like code it in X and WX. It's like, no, scrap that. It's a hobby project. We can make like nonsensical decisions. So hey, we have OpenGL on the Raspberry Pi. Awesome. And we even have it on this thing, and the other thing is runs Linux, but doesn't want to talk to the Beamer. But then I looked at OpenGL, and that's hard. I mean, it must be a hobby project, so hey, NanoVG. NanoVG is not even open source, like a public domain library, which basically wraps around OpenGL. Gives you a nice 2D library. It's a bit like SVG inspired. So now we're back at web technologies, so unavoidable. And it gives you like all the 2D, and it's like for pure mortals like me, they can program a nice 2D thing. So like, okay, we need NanoVG. Number of Elixir bindings for NanoVG, 0. So we need to integrate C code. There are 2 ways to integrate C code. I'm sure that most of you know that. You build it as a NIF. It runs inside your process. I wrote the C code, so the process crashes, and your thermostat is down, and it's minus 25 outside. Your pipes freeze. No. So I'm like, let's use Erlang ports instead, because then the thing can crash and we can restart. And I mean, my thermostat keeps running, and my display might be down. I don't care. How do you use ports? And I have to apologize here for the font size. Maybe you need to scoot up, or my colleague who borrowed me his laptop doesn't have Source Code Pro installed, which is very bad. Anyway, if you send arguments through a port, you basically run it through Erlang term to binary. You send a port command, and the bytes go out, and that is super simple. Now you're in C code, and you have like a hello function, and now you need to allocate a buffer on the stack. You need to call all these EI underscore whatever functions to decode the binary, and then pull data out, and now we have the string back, and we can say like, hello world. So I wanted to add like 1 line of C, and I got like 7 lines of boilerplate. Which is all nice, because if I want to actually send something back, it gets worse. Now I need to, just like 1 line, allocate a window, another buffer. I want to encode like the serialization version of Erlang, a tuple header, process ID, blah, blah, blah. And then I write it to stand it out. And then again, back in Elixir, it becomes easy, 1-liner, binary to term, and you got everything back. So if you look at it, it's sort of like the client code is nice, serialization is nice. Then you got like on the right-hand side, you got all this boilerplate, and that's typing code, and I wanted to get my soldering iron out and attach a temperature sensor, not type C code. I mean, I've been doing that for way too long anyway. And the hard part, of course, is that your serialization, your deserialization must be kept in sync. So I was like, no, let's build a better mousetrap. We're engineers after all. And especially if you don't have a product owner, you can actually go wild with your mousetrap. So let's just let a computer take care of all the hard work, and we focus on the fun work. We do the boilerplate in library, and we generate all the code that is around our stuff. So an example. This is an example of Hello World and C Elixir. Basically, there's some boilerplate, but now it's 2 lines, so I can live with that. Def underscore C says like this is a C function. Then you have like CDA call all the variable declarations. It's something that C wants. And all we have is like a single line, fprintf, standard error, hello world, and that's it. If you call it like a regular Elixir function, which is really nice. You don't need to do all the manual legwork. So how does this thing work? On startup, there's a Gen server which manages this process, which has like all the C code bundled in. It's started up as a port, and then it basically sets it up as a, there's this neat little thing. If you open a port, you can open it in packet mode, which means that if Erlang writes, it sends like the byte length, in this case 2 bytes, and then the actual bytes, which makes reading it very easy. The Elixir code then converts, so this is where the macro stuff pops in. Your hello function actually becomes an Elixir function that just sends the whole thing to the Gen server. The Gen server handles the call. It inspects, it does like a term to binary conversion, so you have like the library code for the boilerplate, sends it to the port, and gives you no reply back. So now we have like the whole call stuff done. In C Elixir, we get the function. We read it, so we get the packet length. We read that packet in a buffer. And the cool thing, the reason I used 2 byte length is that I can allocate static buffers of 65K, which means that modern stacks, even on a Raspberry Pi, are in megabytes. So I can do like a lot of this nested before blowing the bank, and I never need to do memory allocation because someone told me that that's hard in C. Then there's a thing that's actually pretty nice. It's been since 1992, since I last had a chance to do string dispatching to C functions. I'm using gperf, and if you never, has anyone heard of gperf? Yeah, read up on it, and it's probably already on your laptop. And otherwise it's a brew or apt install. Given a list of strings, it generates a perfect hash table. And perfection, of course, is awesome. Because it knows like the whole data set, it can generate a perfect hash table, and your perfect hash table basically is a two-step memory lookup, always. There are like no deep chains or whatever, there are no hash conflicts. If you do that on a modern processor, it is blazingly fast. It's pretty much zero overhead. So it's very simple to have like this string where I decode like module function or encode module function mapped to the generated C function. And then the generated C function is basically the same as the previous example. You decode the argument, and then there's the fprintf, which we took out of Elixir, and we have C. A bit harder is if you return values. So this is how far I got so far with Elixir. I can do if statements. And I can return, and it gets a bit fuzzy there. So I'm writing in the last line there, this is a C code, but I'm just returning an Erlang tuple because I couldn't find a better notation. And the only restriction I have on like this defc macro, of course, is that Elixir needs to be able to at least build an AST out of it. So everything that Elixir can build an AST out of, I can map to C. I know that if there's like in the last line, there's like a tuple, I know what to do in my macro, and I can do like all the conversion back and whatever. And data for an if statement, you know, I can map it to a CF statement, and there's some more stuff. If you really want to cry, you should look at a macro code one day, because it's pretty terrible, but somehow it magically works. So it expands to this sort of stuff to return, and again, it's the same boilerplate we had before, but now it's this whole block here is basically this tuple expression in Elixir. Saves me a lot of typing, and my wrists feel much better now. And then the other thing I thought was sort of neat is that there's no asynchronous wait. So that's why the C function has to send the pit back of the caller. It's all asynchronous. So basically, the gen server reads command packets back from the port, decodes it, expects a pit in the first element of the tuple, and sends whatever it finds back to the caller, or the pit. And so we basically do the same simulation that gen server does with synchronous calls, because it's like a send and a send back. We do that through the port, which means that you can send in, you don't need to worry about synchronization. Stuff doesn't block if you have like multiple calls. And we declare success. I mean, we generate all the code, we have boilerplate library, and all we need to do now is write plain old Elixir code. So then we go back to the original idea, like, okay, we need to render something. And when you write a library in Elixir and you want everybody to use it, you need to call it gen something, I learned. So I call it the JenRenderer. And the JenRenderer basically says, like, it's got a startup method, like, start this JenRenderer on this module, give this the window title, 800 by 600, run it on 100 FPS, and little state argument. And JenRenderer then basically calls this 100 times a second. You paint the background in the UI module, I'll show that later. And then you go through, and this is JenRenderer of a Boyd's demonstration, like bird flocking. I have it on that laptop and not on this one, so I'll put it up and you can actually look at it after the talk. So if you want to render this Boyd's, we have like a model with ETS where the birds know where they are and they change their behavior. 100 times a second, we call the module, give me the state and velocity direction of all the birds, and the UI renders it. And then you get this sort of code, and this is sort of code I like to write. I mean, this is like straight 2D vector graphics. I'm hidden from OpenGL. I don't need to write C and whatever. All I do is say like, okay, paint background. I need a linear gradient, radial one, the sun, and I just go and paint the background. Now let's see if I got my thing set up correctly. This is also too small, so. Command plus. Yeah, well, it works, yay. This starts to be reasonable. So the whole rendering code here is in C Elixir. There's some things here. Here's C code to paint the background, which gets bunched up in the C module. Then we render, and so the fun thing is, like in the actual calling module, it's just calling like paint background and render, and the calling module doesn't know that like one goes to C and the other one stays in Elixir. And if I do like _C there, then suddenly it becomes C code, and this is sort of like malleability I wanted to have, which you can just move code between Elixir and C and do whatever you want. Although, like, expressions like this currently are not parsed by the macro. I'm not going to brag about how good I'm at macro writing, but I'm sure that someone can submit a PR. So I decided to do like the actual render single bird. My graphic skills are so awesome that I could paint a triangle, and then I stopped. I got scared. So basically, I get a triangle, I rotate it, I scale it, I move it. So move it around on the OpenGL canvas to get like absolute position. I flip the y-axis, details. If you have like, I like to calculate like math coordinates, and OpenGL likes to calculate screen coordinates. This looks like Elixir code, and I say like, okay, draw a board with like these anchor points. And let's find where the draw board is. There's a draw board, so it's a C function again. And basically it's like regular vector graphics, begin a path, move to line to root, fill it, stroke, done. And this is sort of like, yeah, we're getting somewhere. Now, my prep talk was like, I'm going to risk it and give a demo. And then nobody told me that my laptop wouldn't work. So there will be later. I can tell you, it works, and it works at 100 frames per second with 50 boards. Which is, so this draw board thing is sent through this standard in output pipe to my little executable 5,000 times a second. And it just works. And it was mind-blowing. Like, oh, I started with one board, and then maybe I can do two. And I stopped at 50, but it is actually pretty quick. I'm super impressed by the Erlang decoding libraries, because you pass in a pointer, you keep your buffer, and just move the pointer around, parse this piece, that piece, that piece. There's no copying. I have like statically allocated buffers. You don't need memory allocation, and it flies. Demo time? No. So clearly, it's not much use if you got flying birds on your thermostat display. So what about this original project? I got smarter. Can I get a shout out for people with nerves? And like an applause, because it is awesome what they built. I built a little specific nerve system. Also, don't ask me to edit your wedding videos. You know that now. I made it all scientific by the timer. So at 0 seconds, I plugged in a Raspberry Pi. It's booting up in nerves. I don't know, this particular build was a bit slow, but I didn't have time to figure it out. I had it down to like 13 seconds. And here's my thermostat display with like an emulated temperature. The weather is not that bad in Ontario. That's like, but it works. So takeaway is, don't be afraid of macros. Don't put limitations on yourself on what macros can do. I mean, you're running code, you can do whatever you want, you can generate C code, you can crawl GitHub, whatever. And ask me questions.
All right, we've got time for just a few questions. Okay, so can you tell us a bit what data types can you send through to the C code?
Yeah, I mean, this is a, how do you call it, minimal viable product? Yeah, no, it's so it's very OpenGL specific. So currently you pass floats, ints, and strings, and then it's got a separate data type for Erlang pits, because if you want to return a value from C, you pass in the pit and you need to return it. So it's like a special data type. So it didn't go in like compound data types, etc.
So you mentioned you're getting 100 frames per second. Did you have any trouble with like hardware acceleration, or especially in the Raspberry Pi?
I didn't run this on the Raspberry. I think I ran it on the Raspberry Pi. It was much slower. But if you use embedded GL on the Raspberry Pi, so Broadcom doesn't tell you anything about the GPU core, but gives you the embedded OpenGL thing. And it was pretty quick. I mean, you are using hardware acceleration, and I think on this machine, I'm not using hardware acceleration. I think it's Mesa, but so it is working.
Oh yeah, it's smooth.
Yeah, it's very fluid, very smooth. And no, I was surprised, but I mean that's not my coding. It's just like how quick OpenGL and even like embedded machines are with their GPUs. So I ran it on the Raspberry Pi. I think I even got it for like for 50 birds, and it got warm, but it didn't die.
All right. Last question.
Have you looked at Scenic at all for the UI?
Yeah, but I was before Boyd, so I win. So background, Boyd announced Scenic, I think Elixir Conf 2017. And I was like, oh, I'm going to do this project. I mailed him like, oh, when is it coming? Like, yeah, I'm busy. And I was like, well, I'm going to try, and I'm going to hope that I write something sufficiently different from what he's doing that we maybe can coexist side by side. I mean, I'm not particularly invested in it. If people want to use it, it's on my GitHub, Cees de Groot. I will accept pull requests. But if everybody says like, well, Scenic is way better, I get it, because he actually knows what he's doing. The difference between this and Scenic, this is very what Boyd calls medium mode. So you like very low level, you render a frame. You got like very low level control. And Scenic is more like scenes and whatever, it's a bit more away from the machine. So there might be cases where this is better, I don't know. Might be that everybody looks at it like, yeah, whatever, we go with the pros. But I needed it before Boyd was done. So
The C interop is still really impressive.
All right. Thank you so much, Cees.
thank you.